Hey, hello, and welcome to the show. It is me, John Park, and it is time for JP's product pick of the week. Thank you so much for stopping by today. We've got people over in our chats. Cloudflare can't keep us down. It seems like the YouTube chat has returned. For me, it disappeared for a moment, but yeah, look, there we are. Hello to Robert Cochran for joining us, as well as Isaiah Grigo. Hope I'm getting your name correct there. Sorry. Beata Gruff, Avdelhagen, as well as Tyrone Mix and Artist. Hello, Artist. Thanks for popping in. We also have this chat right here. If you're looking for Adafruit chat, hey, look, that's even in color. It is the Discord. Go to adafru.it/Discord. Look for the live broadcast chat channel, which is that right there. And join us. So who's joined us? Hey, hello, Liz, Blitz City DIY. Nice to see you. Jim Hendrickson. Hello, Paul Cutler. Byron, good afternoon from Nevada. John Nodge, C. Grover. Hello and welcome. So let's see. I think my commitment to the bit is wavering here. So let me let's bring color back, shall we? Let's reset this. Boop. Hey, look. How nice that we have color. But that is apropos for the product pick of the week this week. What I want to do is let you know if you want to go and check out the product page for this week's product pick. You can head there right now. This show is broadcast from inside of the product page, so you could go right there. The product is on deep discount. We had 100 stashed away, as well as some extras, so there's plenty in stock. And we have, I'm sorry, actually this week I think we had 50 stashed. I lie. There were not as many available. So we had 50 stashed, as well as some extras that were there before the show. All you have to do is throw them in your cart. There's no coupon code necessary. The price is as listed. Buy it before the end of the show, before they sell out. The price goes back up after the show. If they do sell out, we don't take rain checks or honor discount prices or anything like that. When they're gone, they're gone. We like to keep it simple. So before I tell you any more, what I'd like to do is have Lady Ada discuss this week's product pick from the new segment on a recent Ask an Engineer. So please take it away, Lady Ada.
This is a e-ink bonnet for the any Raspberry Pi or Raspberry Pi compatible, anything with this 2x20 header. You can see on the bottom there is a 2x20 connector that you can plug in, and it gives you access. It actually gives you a couple things. So the main thing is this circuitry here lets you support classic e-ink displays. So almost all e-ink displays, not the 6-color ones, but like the monochrome, the tricolor, quad color, they have this standard 24-pin connector. And now you can use them directly with the Raspberry Pi. I would recommend getting one of our extender cables because you would get a lot of space. You can mount this anywhere, and then you can use our Python code to easily draw any image you want on to the display. You can use dithering because you've got access to all the graphics tools that you would on a Raspberry Pi. And we had a little bit of space left over. So in addition to having like the breakout for all the pads, there's 2 buttons, 5 and 6, so you can like change programs. There's a switch to change the resistance. By default, I think 0.5 is what like almost all panels use, but some want 3 ohms. Just flick it over. A JST PH connector with power, ground, and digital 12. You can like connect NeoPixels or whatever. And a speaker, as well as Stemma QT. And the reason I put an I2S speaker on is I figure if you have an e-ink display, you might want to have audio alerts, even though it's not going to be maybe the loudest speaker. It's a like 3-watt max. You could like have some notifications and stuff. And you still have GPIO you can connect to here if you want buttons, or you want to connect I2C devices over the Stemma QT. So I think it'll be a good, like I see a lot of people making pretty cool e-ink projects. I think you could power many interesting e-ink projects with this bonnet. And like I said, it works with any 24-pin e-paper display. And we sell the raw displays as well in the shop. Actually, maybe we'll see, I think. Yeah, one of our bare displays. So we stock, from 2.13 up to 7.5 inch, monochrome and tricolor displays. All these will work. And we have Python drivers for all of them.
Yeah, that's it. Right there. That's the product pick of the week this week. It is the Adafruit e-ink bonnet for Raspberry Pi. This is a project I had built recently using it. So under there I have a Raspberry Pi 5, and then I have our bonnet. Let me, in fact, I'm going to unplug this so I can get this a little closer to the screen. So you can see the bonnet right there. Can I pull that off? I don't think I'll do that. I think I'll leave it where it is. I've got another demo I'm going to show you in a moment. That's also hooked up, and I only have the two of them. But it is your standard bonnet format. So it's got a 2x20 connector, sits right onto a Raspberry Pi or other single board computer that has that same pinout, is compatible with that pinout. And it lets you drive 24-pin e-ink displays, or e-paper displays, EPD, we see that, that terminology used. So you've got, I'm going to go to these images right here. So you've got a 2x20 connector, fits onto the Raspberry Pi. At the bottom in the that little white connector there, that has little tabs, and then you press in the flexible 24-pin connector, and then you're able to drive the e-ink display using SPI. We have a standard pinout, we have examples, and you can run this in using Python with Blinka and CircuitPython, so it's a very easy to set up and use, and we have examples of doing graphics and text with that I'll show you. So what else? The bonnet itself has some pretty neat features. It has the connector for the e-ink display. It has a JST 3-pin connector for connecting up power, ground, and a data pin, for example, using NeoPixels. It's easy to connect to that. We also have the small STEMMA QT connector to connect up I2C things conveniently. A couple more bonuses on there. There is an I2S amplifier and speaker output with that little green terminal connector you see there, so that you can hook up speaker and do some sound actuation or music. We also have a couple of GPIO pins. Pins 5 and 6 are available as those two push buttons on the top. Also, we have a selector switch for 2 different resistance levels depending on the display. I've never had to change that. I've used just the 0.5 ohm setting on there. I haven't needed to change that, but maybe you will for a particular display. This is good for monochrome e-ink. This is good for grayscale, 3-color, and quad color. Those all use this sort of standardized connector. And if we take a look at, let me go over to Chrome here. Hey, what's that? What broke? Let me look at what I added. Why is that doing that? Hey, weird. All right, let me fix this real quick. Sorry about that. Reconfigure to show product page there. Change that monitoring. Okay, you can see that. Yeah, let me put this back here for a second. So here you can see this is a typical display. This is one of the, I believe, 7.5 inch or 7.2 inch tricolor display that's on there. This is the extension and extension cable and coupler that Lady Ada mentioned. So we have that, I think, do we have that over here? You'll find that in some of the docs and projects. If you look at, I'll point you at the Learn guide that I used this with recently. But if we head over to the Learn guide for the bonnet itself, you'll see we've got the little pinout page. We have a description of the connectors here. So on the 24-pin connector, among other things, you've got all of the ports for SPI, the clock, DC, reset, busy pin, all of those are connected and specified there, so you can use those in your code. The resistance, resistor switch, buttons on GPIO 5 and 6, and I'll show you an example that uses these. STEMMA QT connector for I2C stuff, and this JST 3-pin connector that you can use for kind of anything. I'll show you how to use that for NeoPixels, and then the I2S amplifier and the pins that are used there. So if you take a look at this next link, e-ink use, this will guide you through getting your Raspberry Pi set up, using a virtual environment, Python 3, Blinka, and setting up all of the drivers and examples you need to get that up and running, as well as a little example of how to use this speaker here, use the amplifier and speaker setup. So these are some of the displays that you can use with this. These are the ones that we sell. You may find others out there, but we know these work. So we've got this little 2.13-inch monochrome or grayscale. We've got a quad color in 2.6. We've got a tricolor in 2.6, 3.7-inch monochrome, 3.7-inch tricolor, 4.2-inch monochrome or grayscale, 4-color gray. We have a same size for a tricolor. I'll show you an example with, I think I have that monochrome version of that running. So 5.8, and then here's these two 7.5-inch monochrome. That's the one I'm using on my slow movie player project that I did recently, and then there's this tricolor. So those are all different displays that you can use with this. And let's get to the demo. Let me go to a down shooter here for a moment, and I'm going to get my face off of there so you can see everything. So here you can see I've got my Raspberry Pi, so Raspberry Pi 5. I've got the e-ink bonnet on top, and then plugged into it I've got three things. I've got a ribbon cable connector extender for the 24-pin cable that's standard on these e-ink raw displays. Then I have speakers going into the I2S amplifier output, and then I have a set of NeoPixels. You'll see the light from those. I won't put those under the camera because they're very bright. And then I'm going to use these two buttons as well in my code. So here's an example of it just displaying a sort of static welcome splash screen. And let me go to code here for a second and get this running some different code. So I'm SSH'd into that Raspberry Pi from my computer here. I'm going to run this Python code, this demo_ebook. So you'll see it'll do the full screen refresh. And then I'm using I think it's the GPIO 5 button here to switch modes. And you'll hear I'm also playing a little sound effect. And now I'm just showing some sort of example like ebook text, I think in like a 14-point sans serif typeface that I thought looked nice there. And let me just double check, how's this focus look? I think it's pretty good. Yeah, I should have left it alone. All right, that's good right there. If I press the second GPIO button here, I can turn on NeoPixels. So you see, I'll put them under the camera for a moment. Each time I press those, I'm just changing the color of that. So more likely you'd use this if you're doing sort of a e-reader kind of project as some lighting, and you might switch between a few brightnesses and color temperatures of white, but I've just got it cycling between some colors on there. You can see it displaying in my console as I do that. So that's one example. I can press that 5 button again. You'll hear a little sound effect, and it'll switch back over to the splash screen. And I'll go over here, and I'm just going to quit that, and let me run actually, let me go to, this waves demo. I just had some fun doing some graphics on here with some sine waves and changing the amount of those on the screen. So again, I'm using my little amplifier and speaker there to play a little wave file so that I can get some feedback when I press that button. And then I'm just changing the number of waves, amplitude, frequency, and phase of some presets that I did of some waves on the screen. Let me go to the full screen for a moment with that. I can then press this the e-ink Bonnet's button 6 and invert the colors on the display. So you'll see it'll do a full screen refresh, and now I've got black lines on white. Press the 5 button and switch to a different setup there. If we take a look back here at this shell, I'm going to just switch to one last demo, the squares, just because this one's really simple for checking out the code. So this just draws a black background and some white squares on top of it. And if I come over here, I've got a better code editor for showing that code that's running there. So there you see, there's my code for this. I'm using Pill for some image drawing, and I'm using the Adafruit EPD SSD 1683 library to drive this board. So the Adafruit _EPD library contains the chipsets for all of those different raw displays that we have. So this one happens to use this SSD 1683 example code. Liz put together a great guide for e-ink displays that shows example code for every single one that we sell running on this, and all of the different setup parameters that you'd use for those. So then in this case, I'm just setting up white and black. It's the only two colors that I'm using on this display. Here's the setup over SPI using the pins that are defined by the bonnet to run over that 24-pin display. And then this board is defined as 400 by 300. You can do rotations on it, so if you want to use it vertically versus horizontally, I think you can do 4 rotations on that. Excuse me, yeah, so this is set to 0 right here in this case. And then I'm using image draw and display IO. Here's display this simple squares image. In the case of drawing the waves or doing the ebook, more of the same, doing some text stuff with these. And then to use my buttons here and sound, so I'm importing Pygame just to be able to do some of that sound stuff fairly easily. Sound can always be a bit of an adventure on a Raspberry Pi, but I got it working without too much difficulty. So I'm just playing back a wave file. And if you check out here, I've got the RPi GPIO with a button for pin 5 and a button for pin 6, setting those modes and setting those as pull up, down resistors as pull up. And then in the main loop of this, I will, when we detect the button press, call this preset button callback, which in the case of the waves one just changes the display to those different waves. Oh, you're not seeing the code. Why is the code not showing? So sorry. All right. I appreciate the heads up. Let me go back to squares. Okay. Saying that again. So code for just the simple squares demo. I'm importing board, bus IO, digital IO, and then Pill to do the drawing. And then for each of these displays, we have a different chipset, but the EPD library, which I'm porting here, can handle them. So in this case, it's this SSD 1683. Then I'm doing some color presets for black and white. All of my pins defined for SPI setup to draw to the board, and those are pre-configured to run on this 24-pin ribbon cable that we have here. I just have the extension running in this case. Here is some of the display setup. This is all in the example code. Here's our rotation. You can go sideways, vertically, and then the flips of those. And then just using some basic display image display to write those squares to the screen. Here is the waves code, just checking. Yeah, you can see that. Same kind of setup. And then I'm also doing some of this GPIO. Here's Pygame setup for audio, and here is GPIO setup to be able to use those buttons. So button for pin 5, pin 6, GPIO setup, pull up resistors on those. These are my little presets for the number of waves, the amplitude, the frequency, and the phase of those different waves that I was drawing. And this is the callback that I use when the preset button gets pressed and the invert button gets pressed in the case of the wave code. And that's about it. Yeah, so I've also got some examples there. I can call those with specific values if I want to. Ebook is similar, but we're also importing NeoPixel in this case, as well as random, so we can set some random colors. Same setup, setting up display, SPI, setting up audio, using the buttons, and then here's my NeoPixel setup. This is on pin GPIO 12 is the one that's on this GPIO, or rather JST connector here, so you can plug in. This is actually fairly standard setup we have on a lot of our NeoPixel products is this little JST connector that you can plug right into the board and use those there. Don't have an example of Stemma QT I2C, but that's plug and play in there. All right, let me see. Other questions? Let me go take a look and see. Looks like we've got, let me switch to this one here, 64 of them in stock. So go grab some, throw them in your car. You can get up to 10 of them per person. And now I'll check and see any questions. So David WA90NY over in our Discord asks, is there software for displaying the terminal window in the e-ink? I have not tried it. I ran across people discussing this, and I don't know what the answer was conclusively. So worth a search. If anyone happens to know in the chat, let me know. The display, the way I'm using it, I'm in these examples, I'm doing full screen refresh. When you're doing text stuff, you can get much faster, I believe, by only updating the changed pixels. So if you're doing terminal stuff, it would only be necessary to like clear the screen when you got to a full page, or maybe when you want to do a new line. Let's see. Other questions. Would this work on the Raspberry Pi Zero? I know they're stripped down and are near the bottom of the performance envelope. I believe they do. I believe those have this same connector and they can speak SPI. So again, I don't have any recent experience, or maybe any. I don't know if I've ever tried to run an e-ink display. But if anyone knows in the chats, let me know. Oh, say Dale Etchels says yes in the chat. I have a Zero driving a 7-color e-ink display. Show pictures of my grandson. Oh, that's awesome. Yeah, you can use these for picture photo frames. That's kind of what I'm doing with this here. Let me go, actually, that's a good reminder. I wanted to show over in the Learn Guides. If we scroll down on the product page, you'll see we have the primary guide and this e-ink slow movie player. This is a project I built based on Tom Whitwell's slow movie player. There you see I've got it with some Steamboat Willie going on there. So that is this pretty much this exact setup. If you take a look at assembly here, I've got that e-ink cable extender. Lets you just couple a second 24-pin ribbon cable, and we sell that nice long one that you saw in my demos there. So there's the connection to the bonnet, and then there it is connected, just taped down and ready for connection onto the Raspberry Pi. So once the Raspberry Pi goes in, this is, go full screen on that. This is what your setup will look like. You can kind of fold the ribbon around however you need. But that right there is all you need, and power. Raspberry Pi, the bonnet, connection to the display, and you're off to the races. And everything else here is just the plugging stuff in and buttoning it up and playing some images. So those are a couple examples, but if you look, we have other e-ink and Raspberry Pi projects out there, and then there's a lot of them out there on the internet that you can go check out for inspiration. And let's see, anything else? Let me go back to some demos of this here, because I like the way those look. Let me bring up my waves example. These are cool actually, because they kind of give you, these screens are nice and sharp, so this kind of can give you a bit of an optical illusion effect. It would be good for optical illusions if you had spiral kind of ones that create motion just through tricks of your brain. These displays are pretty neat for that. Here's the inversion. I'm going to put my mic next to it when we select the next screen of it so you can hear that. Lean forward and... All right, and let's see. It looks like that's all the questions. Yeah, and since I don't think it was linked in the main page, I'll just show you these two here. This is the extension. It's product 4230. It's $1.35 to get that extension cable. And there is the 86-cent connector that just allows you to hook up the little pigtail of a cable that's on the display to your extension cable, and then you'll get something like that right there. So there we are. I guess I'll dare to unplug all of this now because, hey, it's an e-ink display. It'll stay. Let me do a little shutdown command in my console first. And let's do. Oh, I think I need my connection. Yeah, I don't have Wi-Fi running on this, so it's going to ignore me. Let's see. There we go. Sudo shut down now. Okay. All right. I think I can actually hold all of this at one time. Yeah, that right there is my product pick of the week this week. It is the Adafruit e-ink Bonnet for Raspberry Pi. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I will see you soon. Bye-bye.